Hello, assalamu alaikum. Hello,
Mr.
hello.
Rahman,
Can you hear me?
Walaikum. Yes, Mr. Rahman. Can you hear me?
Yeah, perfect. Yeah.
Thank
Okay,
you.
so how are you?
Good, Mr. Rahman. Thank you so much for taking time and helping me out, joining this session. Thank you so much.
Okay, so now today I will show you that for your study area for the RUSLE model, how we
Okay.
can easily use and then get the perfect RUSLE soil erosion map. So let's just I simply share my screen.
Eh,
So now is it visible?
Um, your screen is not visible. Yeah, now I got that. Yeah, yeah.
Uh, okay. So basically in this time here we use the RUSLE model,
Eh,
and I think this region has some hilly region or high
yeah,
elevation.
yeah. This is all hilly region.
Yeah, so that's why in this time we can get that saver. So in this time we can get the very high soil loss value for that. You can see here. Suppose I simply check it some value for the high region. Suppose let's put a tab and click on this map. So you can see what is the value you can get for that. You can see soil loss is that 9,296. A very high soil loss value you can get from here because it's a hilly region, and mainly hilly
Okay.
region we can get the high salt value, or this is the
Okay.
gradient is also high, so that's why
Okay.
there the soil loss estimation is also high for that. Mainly hilly region
Okay.
we can get find out that. So I think this you can see in this time we can get this value 11,388.34 hectare. You can get this type of soil loss value, sorry, ton. So it's a ton per hectare per year. Okay, and in this time we are also
Correct.
take here 10 years. You can see 10 years. So basically I put here this year of 2010 to 2022, this time period. Between this time period
Okay.
it calculated the total soil loss.
Is it 2022, Mr. Rahman?
Okay, 2022 further I think some data is not available for that, so let me check. Post 2022 which part we can get.
Can you make it 2022,
uh,
say September, October?
yeah, it also possible do that, but for that okay, so let me check. Because in
Because
this time we are using the
uh,
some data set such as suppose charts data set. I think it also available for that to 2022, and which data set not available, it can some
yeah,
problem
it's
for that.
coming.
So we check about the map first, and if possible you also download the data from here and then use the ArcMap software or QGIS software for calculating the area about that, how much area for that, for the saver,
Oh,
how much area, very high, moderate, slight. You can easily calculate the area from here. Okay, so what is your date about the 2022?
22, maybe say October, till October
October
10. Uh,
10, October 1st October or 30. Okay, now let's check about that. And in this time here I put the very high value because you can see I considered the slide is the less than. Yeah,
you got it.
so now it also work about that. I think all of those data is available for that. In this time we take the LULC data. In this time if you want it, you can use that the Landsat data or Sentinel data, but Modis is ready globally data, so you can easily get from the Modis. Okay, DEM is also available, no problem. Rainfall data, so we are using the charts data set, it also okay, no problem. Okay, or if you have own station wise
Mr.
data set, then it also better for that.
M,
There is no problem. Yes.
Mr. Eman. Yeah, for them, is it SRTM 30 meter?
SRTM. Yeah, yeah. SR NASA. You can see the NASA SRTM. 30-meter resolution. This is the demo we are using here. Yep. And this is the charts painted dataset. It provide about that precipitation. Okay. Suppose when you want to need the more accurate result, then it also better to use the ground station or station wise data. Okay. Then make the rainfall map. Then import the rainfall map in here. But in Google Earth Engine platform, we can easily get the global rainfall data from the charts painted dataset. That's why in this time I use in here.
Okay.
That is no problem.
And after
And
rainfall, Mr. Eman, there is a, we have to do the erosivity factor, na?
yes,
Like land use K factor and
yes. So this is the R factor. Well, we calculate from the rainfall data set. Uh, then K factor from the soil data set. And then LS
yeah,
factor from the dam data set. Okay. And this dam data we need to convert into the percentage, because in this dam we can get the, from the dam we calculate the slope. Okay. And then mainly slope we can
yes.
get the degree. But when I just put this type of things, then it calculated into the into percentage. So you can get the slope in percentage.
And Mr. Eman, for the soil data,
Yeah. Okay.
for
For
the
the
soil
soil
data,
data, we
uh,
use here this data, soil US D system, mainly the soil texture,
okay, uh,
and it's the combine the soil texture and level is the 0 centimeter depth. Okay, so basically this data set provide the different depth soil texture, but in this time we take the B0, mainly it's the soil texture 0 centimeter depth. This band we are using here to get the soil texture. Thus, as this type of soil texture you can see B0, it's mainly calculated the description about the CL, CI, CL. So it's the different types of soil texture.
okay, okay.
For mainly it's the
Uh,
global data set for the whole
in
world. We can
this
get
in
this type
this
of thing.
like we have to keep the weightage value, no, Mr. Rahman. How did you keep the weightage value?
Which one?
Yeah, for this soil texture data,
Yeah,
uh, how did we put the weightage? Yani, like for clay soil, loam soil,
yeah. Okay, so
those. Yeah,
okay, okay. So in this time, okay, it show the all of those soil description also in here. But
yeah.
do you want to add here the ground truth data or other things about that?
Uh, uh, Actually, I mean, not the ground truth data. Yeah, yeah. Actually, the ground truth data along with the weightage, like how we do the weighted analysis
Yeah,
by
yeah, yeah,
giving.
yes, yeah. So
Uh,
if you have this type of data, you can easily do it. Suppose you can easily apply the different types of interpolation, such as IDW
mm,
or kriging. So this type of IDW and kriging, then you can easily find out that unknown value about that using the weighted overlay. Okay, so first for that we have to know about the some specific point or location, and also
mm.
need about their value. Okay, suppose some place you know about this value, this value, this value. So now I just make the interpolation. I can use here the IDW. Okay, inverse distance weighted or
Okay.
kriging.
Yeah,
Then it's
Mr.
also
Rahman, like
possible to that.
do we have a soil map for this boundary?
Yes, it also have the soil map, so you can get it from
Can
here.
you see?
So okay, see there. It's the annual rainfall. It's a soil. In this time, it should look like that because it not add the any color about that. So this is the soil. Mainly, it's identify different types of soil texture. So
Uh,
let me check. So just I simply straight 98%. apply. Mainly we can get the total 6. You can see 1 2 4 5 6. Okay,
Okay.
6
Okay.
different color we can get in here. So this is a soil, yeah, and basically it's identify the different types of soil texture. Suppose you can also get it from here. Suppose I just simply click on the Explore tab. Suppose what is the texture about? I want to check. Simply click on here. So now we can check in the soil. You can see the soil.
Can we know what
NDVI.
type of soil is that?
Yeah, you can just soil 6. Okay. So what is the soil 6? You can get it from that your data set information. Suppose what is it 6 about that? You can simply
You
go to here. You can see the band, and from the band we can get that B0. You can see the 6. Okay, you can 6. Okay, this is soil about that 6.
uh, what what is that SACLO?
I think it's a one kind of texture. So suppose I simply search the Google or simply copy. Well, what is that? I think it's a one kind of texture of the soil. It's a sandy clay loam.
Okay.
Sandy clay loam.
Sandy clay loam.
Yeah. So that's why you can easily get this type of things. Suppose you can click in this time. I think the blue color is the all of this in the blue. You can see this type of color. Okay. So just click on here.
Blue.
Then we can check about
Uh,
the soil type. What is the soil type we can get from that? So we can easily get the soil is that 9. Okay. So 9. What is the
9.
9? So simply check about the what is the 9. 9 is that you can see SALO. So simply search the Google. What is that?
Sandy loam.
So then, yeah, then
That
okay,
is
yes,
sandy
Sandy
loam.
loam. Yeah, yes, yeah. Then we can easily get this all of the soil information, texture information from here. Okay, so this is soil data, and
Uh,
also you can see.
Mr. Rahman, can you send me this recorded video?
Okay, I'll send you the recorded now.
Okay. And this is slope, no? Okay.
Yeah, slope. Yeah, slope. And this unit is the percentance. So in this time, 12% can
Okay.
get for
Okay.
the coordinate slope as well as NDVI.
Oh, we need to calculate NDVI also for
Yes.
Russell.
Yeah, so mainly in this time we are using this NDVI for that equation.
For LC factor.
Yes.
C factor.
Yeah, you can see C factor. You can
Yeah.
just add that NDVI. And we can
Uh,
easily get this type of value from where NDVI also you can see NDVI value. And this is the LC value. And we can also get about that the average, mainly it show about the average soil loss between the year of 2010 to 2022, this time period. Average soil loss is the 698 ton. Okay, for this average. And further we are also calculate about this type of things. You can see percentage about that, and you can download the CSV, then you also get the better result for every class. And this type of class you can easily change. In this time here I put here that you can see the slide we can get the 21%, moderate
oh,
mainly
percentage.
400%. You can get about that this type of things from here. And
Oh, 4% of the total area is under. No,
yeah,
no. Severe is 4% only. Okay.
okay, mainly in this time greater than, so greater than mainly suppose all of those greater than 4,000 ton. Okay, how much area? So let me check.
So if you see this thing, the graph is showing different. No, Mr. Sir. Acha,
So it's showing the
moderate.
moderate is the high. Yeah,
Moderate is
moderate. This
yeah,
yeah,
71%. Okay.
yes,
Hmm.
71%. And then yeah,
The orange.
so
Orange
in
is
this time
high.
moderate high.
16. Moderate is more. High
Yes,
is 16. Uh, very severe is very less. More
yeah,
than. Okay.
yes. So basically it's defined on here. You can see in this time. If you want, you can also change it. Suppose in this time when I want to make the class, yeah. So this is the things about that. Okay. So in this time you can say I can put here the 1000, 2000, 4000. Okay, so when I put here the 1000, 2000, 4000, then it automatically set this type of class. Suppose less than 1000, moderate 1000 to 2000, 2000 to 3000, 3000 to 4000, and up to 4000. Okay, so in this time you can easily change it. Suppose your own area, you can simply first of all you can check about that in inspector tab. So mainly in this time, this is our soil loss map. You can see this is the soil loss map. Okay, so now it opening. So this map we are just classified using this condition. So it open here. So this is the soil loss map. Okay, overall this is soil loss map. So now further we are just this map. This is soil loss map. This soil loss map we just classified. Okay, this type of class, total 5 class we classified. Okay, so this is the soil loss map. And further we check about the value. Suppose you can simply check about the pixel value. What is the pixel value I can get? Suppose I think suppose click on here, then we can get that low value. So you can see the low value and high value. Then you can
Blue.
simply put your class. Okay, 5 class, 6 class, this type of class you can simply put and put the value in here. I put here the 1000, 2000, and 4000. Suppose in this time you put here that another class is also okay. There is no problem. Any types of class according to your map. Soil loss map. Suppose in this time here you can see for this I can get the value for that soil loss, soil this value you can see soil loss, we can get that minus 163. Okay, suppose click on this spread, so it also show high about that. So this
Uh,
high value you can see 6000.
this is severe, Mr. Rahman, or moderate on the map? What we are seeing.
In this time it not any class, it just a soil loss map. Okay, suppose ndvi map without classification. Suppose sometime we are just make the ndvi map and then it's just simply classified. Suppose greater than 0.8 all of those pixel value will be dense vegetation. Suppose less than negative all of those value is the water. So in this time suppose this is the ndvi map, suppose this is soil loss map. Further this map we are just classified this type of pixel value or this type of range we are used here and
Yeah, range.
classified this soil loss map, and then we can get this type of map, final soil class soil classification map. Then we are just classified 1000, 2000, 4000. Suppose in this time we can simply put here the suppose in this time we can get here that 3000. Okay, so in this time we can get the result. Suppose all of those will be considered from the 3. Suppose 3000. So click to that and can check the result about the classification. So now saver will be greater than 3000 ton unit. And in this time also you can see when I put here the greater than 3%, now it also increasing about that saver. We can get the 2.1%.
2 point.
1%. Okay, but first time it also when I put at the 4000, then it show very low.
Low. Yeah, very low severity.
Yes. So in this time, suppose you want to also add the more value, just change this type of value and put the sequence. In this time, it show the value less than 1000, then slight less than 1000, moderate 1000 to 2000, then high 2000 to 3000. Okay, and then very high about that, suppose it should about all of those less than greater than 4000 or 3000, about that. Okay,
And
so it's mainly depend on your map. Sometimes suppose when you want to work for that flat region, then this type of value is not considered, because flat region we can get the very low value for your soil. You can simply open the soil loss map and check, it show the very low value. Okay, so then using this value you can simply make the classification.
actually, Mr. Rahman, this area is a very flood prone area, Mr. Rahman.
Yes, yeah, so that's why this is
Ah,
another region for that soil loss.
yeah,
Pardon.
it's a real flood prone area.
Okay, so you can simply check it, this type of value, and then you can get the result here. And further, simply download this TP image from here, and then also you can simply, you can see the, I also add the TP image from here. So simply run it, and then you can easily work with dark map or QGIS software for making this map,
Okay,
as well as
per
yeah.
se, if I want to save the first rainfall map, Mr.
Yeah,
Rahman.
yeah. So first for that, suppose you want to export the rainfall map, as
Yeah,
well as also other types of parameter which you want to use in
yeah.
here. So
For
for the same
making
process,
final
yeah,
map composition.
yeah. So for that you can see here, just simply use the same code. Same code mainly which code you want to use in here for exporting the this type of map. So I use the same code, just simply change the value, variable name. Suppose
Very,
here you can see, suppose, yeah. So this is the things about that. Simply copy. And in this time, here I put here the 1000 meter. In this time, for the small region, because in this time you can put here the 30 meter is the okay. So there is no problem. Try to 30 meter scale resolution. So in this time, just suppose you want to work for that in a rainfall map you want to export. So for that, first of all, you simply call the rainfall. You can see this rainfall or annual rainfall. Okay, so this map is already stored in a variable. Okay, already stored
yeah,
in a
yeah.
variable. Just try to find out this variable name. Okay, what is the variable name about that annual rainfall? So you can simply
Yeah.
type here. Suppose simply type here annual rain. So here you can say I can get the annual rain. Okay? This is the annual rain. Mainly it's my layer name, annual rain.
Yeah,
Simply copy
yeah.
this variable name. Okay? Simply copy and then paste.
And this
Paste it.
rainfall is for how many years, Mr. Rahman?
Okay. For the rainfall, same. Okay. Suppose start date and end date, I already defined for all of those data set. Year of
Yeah,
2010
yeah.
to
That's
2022.
acha, from 10, okay.
Yeah, 10 years. So put here the suppose rainfall description. Then in this time you have to also need to check about the rainfall data set scale, because it's the individual. We use here the charts data set. It had also own scale. So this scale is that you can see the bands. Here you can see the scale. Okay. So simply copy the value about the scale and put on the export option. Export option. Okay. So now this code is ready for exporting the rainfall map for the study area. Same process. Suppose you want to export the R factor or soil or also K factor, slope. So just find out this variable name. Okay, then put here and also check about the scale value for the soil scale value, slope scale value. Okay, then mention it here. Then you can easily download as a tip format. Click to the run. You can see our task will be running. From here, we can just simply download the data or export this TP image for individual parameter. So here you can see rainfall. Okay, and click to the run. It also downloaded the rainfall map. Okay. Any question, please?
Eh, the I will be exporting all these individual maps, Mr. Rahman. I will go through one by one.
Yes. Suppose in this time simply copy the same things from also simply copy. And now I want to export about that. Suppose after the rainfall, I want to export here from that. Suppose K factor. You want to export the K factor. So same approach. Just
R
simply
factor. Ah,
R
okay,
factor. Yeah.
okay.
Yeah. R factor. Yeah. So simply you can simply control and F. Okay. Control and F press. Then you can get the search box. Now simply write here the R factor. Okay. So now you can see R factor is the coming. And this is the R factor. Here you can see the layer name R factor. Okay, because I want to export the R factor. Okay,
R
and this
factor.
is the R factor we can get in here, and it's already stored in a variable. This variable is the R. Simply copy the R and paste on your code in here. Paste and put here the suppose description. I put the description is the R factor. Okay, you can put any name. I put the R factor, and in this time R factor mainly generate from the rainfall data set. So that's why I simply use the same resolution or scale value. Click to the run. You can see here. So now another layer is also added in here. Your task tab will be running. From here you can easily get the R factor map also export as a TIFF format. So you can see R factor. Suppose in this time you want to export suppose another
Like
suppose soil
from
map.
here, once you click run, it
Yeah.
will export into TIFF, GeoTIFF.
Yeah, geotip. Yeah, geotip or tip format. Further, we are easily make the map using the QGIS or ArcMap software. Or we can easily use. Suppose in this term soil map. So you can say soil, SOIL. So if find out the soil, so simply control and F. So right here SOIL, soil. I can get the soil. Okay. So basically this is the soil map. Okay. So this is soil map. You can see the soil. And now I want to export it. So simply simply soil. I copy this name file. I want to put on my export function code. So before okay, so for that, okay, just I simply copy from here.
That R you have to take out from there. Image R.
Yeah, R means R factor. It's come from the rainfall dataset
Ah,
and paste here. And in this time, I just export the soil. So just put here the soil. You can put here the description is the soil.
yeah.
Okay, and now you have to find out about the soil dataset scale value.
Scaling.
So simply go to your dataset. You can see the scale. This scale is that 250 meter resolution. Simply copy this value and paste. Okay. So now after that, using the soil, we are just use the soil. We can find out the K factor. Suppose you want to export the K factor. So for that, Control and F. Simply search here K factor. Okay, we can get the K factor. You can see we can get the K factor map. So just simply copy this variable name K. Okay, simply copy the K and again write the function export image to drive. Okay, just same function K. I simply paste in here and copy it and then remove it. It's not need and simply paste here. Soil is not need. I just put here the description is the K factor. You can put any name K factor. So now K factor is come from the soil. So that's why it's the same resolution 250 meter. Click run. So now it also added the K factor in our task tab. So further we can simply download it as a TIFF format of the K factor also from here. You can see K factor also added in here. So same approach, also apply the slope. So first of all, suppose slope you want to export. So simply search here. Slope. I can get the slope in here. So this is a slope. Okay. So simply copy the slope because I want to export the slope map. So now simply go to this code and paste here. Okay, so in this time I do it for faster writing the code. Okay, so that's why I do that. So because only change the variable name. Suppose
Yeah, yeah.
I paste in here. In this time I need the slope, and then change the description. Suppose put here the slope.
So,
In this time, what is the unit? Name resolution is a 30 meter. NASA is
yeah,
30 meter.
yeah,
So
yeah.
put here the 30.
30.
So now click to the run. It also added the slope map also. Then I hope you can easily do for the NDVI, CMAP, LULC, PFAP
Yeah,
also.
yeah.
So you can easily same process. Just try to apply and export from here. So click to the run. Then it will be exported. So then further we can easily make the map using the ArcMap or user software. Okay, any question, please?
Yeah. Thank you, Mr. Rahman. Thank you so much for
Okay.
helping me this. Actually, after this one, then if once I prepare all the maps and other things, Mr. Rahman, I'm
Yeah.
actually last August September I have published one paper on flash floods on this area.
Okay.
Yeah, published in a very high impact journal, a Swiss journal. Now looking for this soil loss as well
Okay.
because of that. And the other one, what I was talking to you, Mr. Rahman, we have the tree data. Each and every single tree data we have
Yeah.
in the region. Okay,
Yeah.
in this same area.
Okay.
Okay,
Okay.
with the lat longs and the tree names
Okay. Good.
in Excel file, and
Yeah.
also as a shape file.
Okay.
Eh,
Okay. It's a,
yeah,
okay. So it's also possible to that. Suppose it's mainly ground truth data is already available. So
yes,
for that, first of all, we have to make it in the CSV file format, and
okay.
then we can easily export the CSV file format. In this
In
time,
well,
I think high resolution image for the specific trees,
yeah,
high resolution image is better,
yeah.
and freely available high resolution image is the Sentinel-2 satellite imagery.
Sentinel
Okay.
2 will be useful now, Mr. Raman.
Yeah, it also okay. I think there is no problem. And this tree is the single tree or just like as a paddy field or crop field.
No, 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 no. It's a single tree.
Single. Okay, so single
Single.
trees is
You
okay.
know,
Basically,
desert,
12 meter.
desert
Yeah.
will have single trees, like they call acacia and all.
uh, Okay, we try first we try using the
Ah,
Sentinel-2 satellite imagery. Then check about
using
the accuracy. What is the accuracy we can
ML
get?
algorithm we will be using, Mr. Raman? Say
So
random forest and all.
yeah. So
Yeah,
in this
VM.
time, all of those trees are the same.
Yeah, no, 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 no. There are different trees here. There.
Okay, for the different trees.
Yeah, there are around say around 5 to 6 species.
Okay, then I think
Ah,
okay. So in this time you find out the classified the different types of species. Yeah.
yeah, yeah.
Okay, then it's some difficulties to that. Okay, we try first about that. Check about the result for that.
Ah,
Okay,
ah,
and
yeah,
if possible, you can just try to make the CSV file
yeah, yeah,
different CSV. Suppose we can just make the group about that species and then make the CSV. Suppose
yeah.
total six species, you make the six CSV file.
Acha, acha, acha. Okay, okay.
Yeah, it's better. Yeah.
Ah,
Okay,
okay.
do
You
that and send me that. Then I check about this in this code what we can get the accuracy and then we can.
okay, okay, okay. And that is for a little extra area, Mr. Rahman. And not this is just Fujairah city. You have another say around 600 square kilometers, like behind this area.
Okay. Okay. So for that you also make the shape file is also better.
Yeah, sure, sure, sure. I will also send you the entire
Yeah.
emirate area, and also as I told you the Excel file.
Yeah. Yeah.
for different species, different CSV file.
Yeah. Yes. Yes.
And also, Mr. Raymond, can you please send me the this code?
Okay, I also send you this code. You also try to practice, and then
Practice,
send me
and
the
then
other file.
yeah,
Okay. Okay. No problem. Okay.
and also this video. I mean the recording link.
Okay. 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 No problem. Okay. Send you. Okay.
Eh,
Okay. Today's now. Okay. Have a good night. Okay. Bye.
thank you, Mr. Rahman. Thank you so much for everything. Yani, I will
Okay.
again, I will once that the trees one is over, no, successfully, then I will help you on, sending you some amount.
Okay. No problem. Okay. Okay.
Okay, for those for the tree classification.
Okay. Thank you. Okay.
Okay, okay, Mr. Rahman. Thank you so much.
Okay. Thank you. Okay. Bye.